5.4, factor and solve polynomial equations. So this will be all different kinds. The big thing we have in here is the sum of two cubes and difference of two cubes that follow the SOAP pattern. We can also factor by grouping or just pulling out like the greatest common factor, things like that. The first problem, say to factor the polynomial completely. So we're just simplifying it out as much as possible. So 4, we've got 30b cubed minus 54b squared. So what is the biggest thing I can take out of both of those pieces in terms of number and variable? 6b squared, and that leaves you with 5b minus 9. Now, if you had said, well, I know I could take out a 2 or something like that, and then you got it down where you needed to factor something else out, like just keep going if you didn't see that like it was 6 or whatever to begin with. Just make sure that each piece is like as simple as possible, and you would be done with that one. 6 z cubed minus 6z squared minus 72z. So for this one, we want to first see if there's something we can factor out of all three pieces, and then from there, since it's three pieces, if we can factor it further, we will. So what can come out of all three pieces? A z. And then that leaves me with z squared minus 6z minus 72. Then can I factor this down farther? What factors can I have? So we're looking for factors of negative 72 that add up to equal negative 6. Let's do this. Let's break this down. Okay, yeah, negative 12 and 6. Okay, so you could break it down into smaller pieces and then start finding the terms that you need if necessary. So then, because this just has a 1 in front, we can go straight to that this is z times z minus 12 times z plus 6. Now, the other thing, if you need to have the intermediate steps, because I know, like with my mom, you would have done the intermediate steps for this, you would have had z squared minus 12z plus 6z minus 72, and then you would have broken this down into, you would have taken out a z and left with z minus 12. Then over here, you would have taken out a 6 and been left with z minus 12. And then from there, we'd end up back here. So if you need to do the intermediate steps, that's fine. But if you can just write these factors, once you find these, then you're fine. Now, if there's a number in front, you need to actually write it out. But it's fine if you can do it like that for those ones. See, 8. 54 m to the 5th plus 18 m to the 4th plus 9 m cubed. What can I do with this one? Can take out a 9m cubed. That leaves me with 6m squared plus 2m plus 1. Can this be factored? So I would need factors of 6 that add up to 2. Right, there are none, because it would either be 6 and 1 or 3 and 2, and none of that combined gives you 2. So that would be as far as you can go on this one. All right, into the new stuff. Sum or difference of cubes. Factor the polynomial completely. 10, x cubed plus 8. So this is our sum of cubes, okay? So the first time we multiply it, or we like do the first part of it, okay, it is, we copy this down. So this is x cubed plus 2 cubed, okay? So when I'm using the numbers to fill in, that's the numbers that I'm using. So this is going to be x plus 2. So this is the same sign. Then it's the first term squared, so x squared. Opposite sign, so minus. The first term times the second term, so 2x. And then always positive, so plus the last term squared, so that would be 4. And that's all you have to do. Um, 12. 27m cubed plus 1. So this first term here is 3m cubed. So when I'm doing that part of plugging it in, like I did up in this previous one, I'm using 3m as the whole piece that's getting done, not just like the m cubed, it's the whole thing. And then this is plus 1 cubed. Okay, I write it that way because some people get confused and think this isn't a like sum of cubes because the one doesn't have a cube on it. And I'm like, well, 1 cubed is just 1, so that's why it doesn't. So anyways. All right, so 3m, same sign, so plus 1, times the first term squared, so 3m squared would be 9m squared. Opposite sign, so minus. First term times second term, so minus 3m. Always positive, plus the last term squared, so 1 squared is just 1. And that's it. $14, 27a cubed minus 1,000. So first piece here, just like the previous one, is going to be 3a cubed minus, what cubed is 1,000? 10. So that's 10 cubed. So now notice the difference in this problem and the previous ones is this is a minus sign here. So we've got first term 3a, same sign, minus, second term 10. Then the next one, first term squared, so that's 3a squared, which is 9a squared. Opposite sign, so now this is a plus. First term times second term, so that's going to be 30a. Then always positive. Last term squared is 100. 192 w cubed minus 3. Now, this problem setup looks like the other ones. However, is 3 something cubed? No. How about 192? Tristan says, I don't know. But the answer is no. But do you think I could maybe possibly take a 3 out of both pieces?
Yes.
And try that? Okay. So I'm going to factor a 3 out. So I'm going to have 3 times, what is this, 64? Yeah. 64w cubed minus 1. Now, is this a difference of cubes? Okay. What is 64 like? What cubed is 64? 4. So this is going to be 4w cubed minus 1, and then times the 3. So when I go to do this, I'm going to write the 3 out front so that I don't forget about it, and then I'm just going to disregard it and do my difference of cubes. So what would I have here?
12
What goes in the first parentheses?
First thing squared. So 64.
Oh, 4W.
Look, up here. Term was 3a, term was 10. I wrote 3a and I wrote 10.
16W squared.
4w minus 1. Okay, the first term is just a direct copy without the cube on it. Okay, there'd be a little just for visual. Okay, now the next term is what y'all been trying to tell me. Is what? The first term squared, which is 16w squared. Then, what is happening? I'm not even touching this. Okay. Then the next thing, or the sign here would be what? What's the sign? Plus. Yep. Same sign, opposite sign. Now what goes in the middle? 4w. And then what's the next sign? Plus and 1. There's not any more examples of that, but I can go find some if we need to do more. Do we feel like we got it, or are we good? Do we need to do some more? Good for now? Okay. All right, factor by grouping. 18. X cubed plus x squared plus x plus 1. So factor by grouping. These ones are just like what you do after you do the initial factoring for a typical just like 3-term thing. So we group the first 2 things and the last 2 things, and we factor stuff out. So what can I factor out of this grouping here? And what does that leave me with? X plus 1. Over here, I can't factor anything out, but I still technically am factoring out a 1. Okay, so x plus 1. These two have to match. Okay, they do. So I have x squared plus 1 times x plus 1, and that is it factored out. Um, 20. N cubed plus 5n squared minus 9n minus 45. So What can I factor out of this first grouping? N squared, which leaves me with n plus 5. What about this grouping?
Negative 9.
Negative 9. Okay, because that leaves me with n plus 5. And I need these to match. So now I have n squared minus 9 times n plus 5. Am I done with this one?
No.
No. Do you know what I need to do?
You know the first one. Probably,
What do you mean?
You can,
This is a special type.
yeah,
Do you
Oh.
remember what it is?
n plus 3, n minus 3.
Yep, it is a difference of squares. So this piece will factor into n plus 3 and n minus 3. And then times the n plus 5. So we have to make sure when we do grouping that if there's something else that I can factor out at that point, that I go ahead and do that. Let's see. I think we're good on that. All right, there's also a set of problems that says factor the polynomial using any method. So most of these other ones have, like, they've just said factor completely. But like these ones specified what method to use, but like that was the only option that you could use to do these ones. So I'm gonna jump down and do one of these. 48. 32 x to the 5th minus 108 x squared. Ideas on what I should do with this one. What's the first thing I should always look at when I have two numbers that don't like directly look like they can be factored? Huh? See if there's something I can take out. I want to try to take out the biggest thing, okay? So I know 2 will work because both numbers are even. Is there something bigger I can take out?
6. And 4.
I don't think 6 works.
You think it's 6?
Okay, so 4. So let's try 4 and see what happens. I'm pretty sure, yeah. So words. So we have 4. What about the variables?
X squared.
I can take out an x squared. So that leaves me with 8x cubed minus 27 by itself. Yeah, okay. Now, is there anything else I can do? Sometimes that's all you can do. But with this one, is there something else I can do at this point?
Yes. You can.
What is it? So when I get to something like this and I see this is cubed, yeah, I'm going to look and see, well, when I see that there's a cubed variable here, I'm going to see if these other things are also cubes, okay? So this one is 2x cubed minus 3 cubed, okay? So now, bring this down, 4x squared. Now what do I do?
2x minus 3.
Yep. So same sign. 4x squared.
Plus negative 6 or 6x. plus 9.
Yep. And then at that point, we're done. All right, any questions on this stuff? All right, problems then are going to be, and you'll have tomorrow to do this as well because we're not quizzing till Friday. Let's see, 3, 5, 11, 13, 15, 17, 23, 43, 45, and 49.